Hello. Is
Sir?
my voice loud and clear?
Sir? Yes, sir. Good morning, everyone. Uh, I am Dr. Sunita Regdi, HOD ECE, SVP EC, and today is the third day of our session exploring electronic cutting edge technologies. So today our guest is Dr. Srinivasa Varaprasad Garu. Um, he completed his MTech in R&M and PhD from both from Andhra University. He pursued his PhD, that is full-time PhD on nanotechnologies, and he's having uh, a very good experiences, that is teaching and supervision, academic leadership, administrator. He's a very good researcher, and he's having two SCI and two Scopus journals along with UGC approved journals, and he's also having one patent that is published. And today we are going to have a session on cutting edge trends in nanotechnology and wideband materials. Welcome, sir. Now the
Thank you
stage is
very much,
yours.
madam. Thank you very much. And first of all, very good evening to all the dignitaries. First of all, Head of the Department TCE, Regidi Sunita Madam Garu, Doctor, and Administration of Sanketika Vidya Parishad, and all my fellow colleagues and all the students. Madam, shall I start my session now?
Yes, sir. Yes, sir.
Is my presentation is okay there?
Yes, sir. It is visible.
Okay. Very good evening. And my topic today is cutting edge trends in nanotechnology and wide bandgap material. Here in this presentation, what I want to give to you people is so what is nanotechnology and how it is influences the past people and present people and future people, and what is wide bandgap materials and what are the different applications of that wide bandgap materials, and what are the opportunities are there in nanotechnology, and along with some of portions of my research. And finally, I gave you some of my projects which are currently ongoing or on board. Okay. Coming myself, I am Dr. H Srinivasa Varaprasad, Assistant Professor, RGUKT-SKLM and Andhra Pradesh. And Sunita ma'am is very well nicely give my introduction. And thank you very much, ma'am. Sir, my next slide, please. Yes, these are the contents of my presentation. Okay, alignments may be changed a bit of compatibilities, no problem. And these are the topics I'm going to give you about nanotechnology and history and industrial revolution and trends in nanotechnology, nanoelectronic devices, research gap in material classification, wide bandgap materials and its application, and steps in fabrication, simulation, and fabrication process. Next slide. And preparation and characterization of ZNO TiO2 doped with SnO2 or CiO2 composition and its thin film preparation, and along with its sensing possibilities and abilities of that material. And the last, I want to give you opportunities in nanotechnology for ECE students and what they need to do to get a good opportunities in this domain. And some of the projects made by me and my students I am attached in the last in my publications. Thank you. Next slide. See what is nanoscale. Okay, see you know very well what are the different scales we have. So for example, if nanotechnology means it is not a 10 to the power of -9. So it is a range from 10 to the power of -6 to 10 to the power of -9 is called as a nanotechnology. So in our electronics point of view, we have a millimeter technology, centimeter technology, nanometer technology. By this range, so what is the nanometer is 10 to the power of -6 to 10 to the power of -9 range. Above the 10 to the power of 9, we can call it as a pico. See here in this slide, I give you at your left side the natural things which we are have from micrometer centimeter scale to or nanometer, and another one is things will be done by man-made. Okay, and here for natural things where the ant is at 5 nanometers level, and dust mate it may be 200 micrometers, and finally DNA is approximately 2 to 5 nanometers. So these are the natural things. And what are the man-made things is head pin is approximately for 1 to 2 millimeter, and the other images are MEMS devices which are fabricated at the scale of centimeters range. And the last one is a graphene, and the colorful one which is with the blue and green is at nanometer level. It is different portions of the atom at micro and nano scales. And the definition of the nanotechnology is a very prominent one, where the nanotechnology is the science, engineering, and applications of the material and a device at the nanoscale, typically 1 to 100 nanometers. That's what I'm telling you, 10 to the power of minus 6 to 10 to the power of minus 9 meters. And it involves the manipulation atoms, molecules to create a new structures, materials, and system with a unique properties and functionalities that are not observed at a larger scale. Okay, we are actually an electronic guys. So what we will do with this nano electronics? Okay, for that one, see what is the Moore's law actually says that for every 2 years, the number of the transistor on the chip will be double. At the same time, the size of the chip will become half. And what is about the cost? It should be reduced or half of the cost, which one is the previously, and occupy. So these are the points will given by the Moore's law, and it is started it in the years of 1950s and 60s. By 2020s and 30s, now what is the size of the transistor? So the size of the transistor is approximately in a nano level. Okay, so where we can see these transistors in a microprocessor, right? So that we have nowadays what the mobiles we are using is operated with a 9 nanometer process, 5 nanometer process, 3 nanometer process. You are already aware that. So the nanotechnology already introduced in the electronics, and it plays a role in an electronic area. So I'm a purely interdisciplinary guy, and I can interrelate the nanotechnology with the electronics and nanotechnology with the other domains too. And here, what are the key aspects of the nanotechnology are? It works at atomic and molecular level and leads to enhanced mechanical, electrical, chemical, and biological properties used in a medicine, electronics, energy, and environmental sciences. Next slide, please. So here I have one question. Is nanotechnology past technology, a very ancient technology, or very old technology? No, no, no. It is a present technology, or currently we are doing with nanotechnology. No, no, no. It is a future technology. In future, we may get a nanotechnology. So what is the status about nanotechnology? It is a past technology, or is a present technology, or it is a future technology? You can give a comments on it. Chat box is open to you all, and very happy if you are going to reply whether it is a past or present or future. Okay, next slide, please. Next slide, please. See here are the some images given. The first one is right. It's a stick of matchbox, right? So initial days when the fire is going to invented by the ancient people, then they don't know what is the particles released from that matchstick. Okay, so where the carbon soot comes from, that matchstick is also a carbon nanoparticle. So nowadays, which we are called it as a graphene or and these applications. So these carbon nanoparticles already they have in their ancient days, right? And next one is Lysergus cup. So what is that cup is? See, you can see the same cup twice, right? At the left side we have one image, and right side we have one image. And what is the specialty of that cup is if you pour a liquid, cold liquid, it will look in a different color. if you pour hot liquid, and it will be look in a different color. So then it is not a magic or a miracle. So it is that cup is made with nanoparticles and nanomaterials. So the illusion and the light which is travels through that cup will give the different colors. And the next image, yes, and the next, okay, and the next image is nothing but gold particles. So gold particles in a liquid. So it is a liquid of gold, so which is having gold particles. Okay, if I tell you the color of the gold is not darkest yellow or thickest yellow, then could you believe it or not? So you should believe. What is the reason? You see here, the liquid in that three bottles is the same. It is a gold liquid, and what is the particles in that liquid is also a gold nanoparticles. But you can see where the violet one is 100 nanometers length of gold particles, which will absorb the wavelength of approximately 575 nanometers, and where the red one is 20 nanometers gold particles, so which are going to absorb 521 nanometers, which is giving a red in color, and 1 nanometer gold particle are going to absorb the wavelength of the light at 420 nanometers and give a color of brown yellow. Okay, so that the color of the gold at a nanoparticle level is a depends on its a particle size. If the particle size is varied, here the color is varied. Okay, and the other properties also varied. And the next of that gold particle, we can see the DNA. So that is also a nanoparticle. So which is having all genetic things in it, so which is also at an nanorange. And the next image, which is you are having a right side, is a very colorful image, right? So it is nothing but a copper particle, titanium particle, and zinc particles combination, which are going to give a different colors. So many years are going there, but the that are still very glorifies and very beautiful. What is the reason behind it is also a nanoparticles which is used as a paints in that image. Okay, so that is the nanotechnology in the past. So from the ancient days, we have a nanotechnology. Please, next slide. And nanotechnology in present. So what is the nanotechnology in present? We can give it with different names. For example, here I mentioned some of them, right? Medicine and healthcare, we are going to use nanotechnology. Electronics and computing, we are going to use nanotechnology. Energy sector, we are going to use nanotechnology. Environment and sustainability, we are going to use nanotechnology. Aerospace, automotive, and customer products, we are using nanotechnology. Okay, nanotechnology is everywhere. For example, it's not a joke. While we are starting from home, we are applying some cosmetics to our face. It is a powder or some other creams. So that is also nothing but nanoparticles or nano powders or nano compositions. Okay, so nano we are carrying everywhere while we are moving with us. And here the applications at medicine and healthcare is targeted drug delivery and nano imaging and diagnostics and antibacterial. So nowadays, you know very well where the cancer hospitals are working with nanotechnology and robotics. The both are combinedly operating to clear the cancer cells or tissues from the human body. So it is all possible because of nanotechnology. And we are having an advanced gadgets which is giving minute to minute responses. It is also because of the nanotechnology. And of course, your mobile biometric. So where you are giving your mobile biometric and give your heartbeat and your blood diagnosis. It is also an application of nanotechnology and nano devices. Next one is electronics and computing. So as I said earlier, so now what is the size of the processor in your mobile? So the size of the processor in your mobile is 5 nanometers, 7 nanometers, 9 nanometers. So then a VLSI and embedded is also will come to that size, nano level. You want to go for a design, a new device, you go for a nano level. Okay. So that is how the nano is occupied the electronics and computing. And where the size of the size of the chip is smaller, and it will be performing faster operations. Okay. So here, what is the one thing is, if we have suffered with some fever, then what the doctor said, please take some light food like idli. So what is the reason to take idli while we are suffering with fever or some other problems? So idli will produce as the smallest particles in our human body, which will give a higher energy. If the particle size is become lesser and lesser, then the energy will become more and more. So similar, like if the size of the transistor will become smaller and smaller, then it will be very faster, right? So that is smaller and faster chips. And flexible and variable electronics. So now we are carrying, what is the electron gadgets are flexible, variable, and transparent. Okay, so now what the technologies we are called as a 5G or 6G technologies, all are virtual technologies. Those devices need not any support, so it will be working or functioning an optical illusions or optical lights. Okay, so that is the nanotechnology. And improved batteries. So you can observe this thing up to last 2 months back. So what is the maximum power of our mobile batteries they are going to give? Only 5000 mAh. So what is the reason why they are not exceeding that 5000 mAh? If it is exceeded and it is not compatible with your motherboards of your mobile, then it will be again another problem. So that till last 3-4 months there is a no extension of that 5000 mAh. But nowadays you can see the almost all latest batteries, mobile batteries, are coming with 6200 mAh or 6000 mAh or 5000 mAh or 6000 mAh for. So what is the reason behind it? They are going to use an advanced nanotechnology in their fuel cells or in their batteries of their mobile, so that without extending the size of the battery, they are able to increase the power of their batteries, right? So that is improved batteries in electronics and computing. With a nanotechnology, they are using the solid state physics techniques and solid state technologies to improving the power levels of the batteries without increasing the size or without increasing the weight of the battery, so that your mobile weight is not changed, your mobile size is not changed, but the power enhances in your mobiles. So that is the best example how the nanotechnology will help in a batteries in electronics and computing. And next one, energy sector: solar panels, fuel cells, hydrogen storage, and energy efficient coating. Solar panels. So initially, the power which is produced by the solar panel, the efficiency of the solar cells are very lesser. It may be 20% or 30%. So that the people are thinking whether this one is used or not. But now the state or central governments are suggesting only the solar panels. How they are giving their publicity: you can take the power to your home and you can give it to the power to the others. So that is the way how we are going to use the solar panels. What is the difference? The difference is only the material made, the solar cells materials made. Okay, so nowadays what is the materials we have are providing very high efficiency to generate very higher powers, so that the solar panels and nano technology influences very higher. And fuel cells and hydrogen storage is a very difficult task, but nowadays the hydrogen engines and electrical engines are become very common thing. And because of this nanotechnology only, so somewhere you can see they have, while they are giving some engineer, they are adding some packets to your bikes. That packets is also consisting of a nanoparticles. Now that nanoparticles are included in that what is that engine oils what they are going to provide. So that is the fuel cells and hydrogen storage. And the fuel cells also efficiently separating the hydrogen and oxygen from the water, so that we are getting hydrogen, oxygen, and along with some power. Okay, so it is also possible by the nanotechnology and the advanced nanomaterials which are used as an advanced membranes. And next one, energy efficient coatings. So what is coating? So initially paint as a paint, wall paint, but now the paint is not a paint. That paint is a dust proof. That paint is a waterproof. That paint can change its colors. So nowadays the coatings are very energy efficient. It can be used anywhere where the transparent coatings are used on the glasses, which will become a bulletproof and very protectable. And that OLED technologies, these all are only a transparent technologies are made with coatings. Next slide, please. Next slide, please. Next slide. Thank you. So next one, environmental and sustainability. So water purification, air purification, and self-cleaning material. So now you can touch your mobile with your dirty hands. So there is nothing will be changed to your mobile. Maybe it is part come from mobile to human body. It is a different story. What is the reason? So your mobiles are made with self-cleaning materials. The materials cleans itself. Okay, it won't take anything. So how it is possible? Because of the nanotechnology and nano coatings, right? And sustainability is provided because of the coatings which is provided on these kind of material. And air purifier, what I said. So your paint can be used as an air purifier. Your paint can be used as a water water resistant paints because of all of nano compositions. And next one, aerospace and automotive. So here I gave you an example of an automobile. So where we are going to use lively different kind of nano technology, like heat reflecting glazing, reduction of engine wear, and scratch resistant coatings in their paint, and fuel cells at their engine, efficient catalyzers to take its horsepower and increase its speed, and nanos shoot particles for better grip from the tires, liquid crystal mirror. So these all are the nano applications. So this is a one way. So if you go for a sensors, okay, then your entire automotive will be a combinations of the sensor, and you need not to do anything. The sensors can do everything in automobile. So all that are purely invisible. Okay, reason they are also at a nano level. Okay, so that aerospace and automotive industries are occupying nanotechnologies like lightweight and strong material. For example, fly high materials are made with very low weight, so that they can go very higher distances. So lightweight is needed, but at the same time we need a strongest material. And scratch resistance, anti-corrosion coatings, which are at normal water and salt water. Anti-corrosive coatings are help very much. And smart tires, so which won't skid at a very frictionless environments. Also they can hold their grip because of this nanotechnology and nanomaterials. And consumer products, so I gave that image, right? So you can see the cosmetics and sunscreens are also a nano compositions, and food packaging is made with a nano compositions. Textile, okay, no need of wash because of nanotechnology. And clothing, these all are some of the live applications presently using applications of a nanotechnology. So nanotechnology is occupied our farming fields, our daily products, our automobiles, our hand mobiles, and our house walls, everywhere. Nanotechnology, the currently occupying everywhere, right? So that nanotechnology is not only a past technology, it is also a present technology. And my next question is nanotechnology is a future technology? Obviously, it yes. Okay, go for a next slide. Go for a next slide. Thank you. Nanotechnology in future. Okay, what is nanotechnology in future is, so we can manipulate. The nanotechnology itself is a manipulate the things. The nanotechnology will manipulate properties. The nanotechnology will manipulate the shapes. The nanotechnology will manipulate the sizes. The nanotechnology will manipulate almost all properties: physical properties, chemical properties, mechanical properties, thermal properties. So that it is now in future, with the help of the artificial intelligence and machine learning, deep learning techniques which are added with a nanotechnology, can do their things its own. Like they can also modify the DNA. It is not a joke in future. Next one, the electronic industry. It is almost occupied nanomaterials, but as you know, so we are in the era of 5G, 6G. the existing electronics is not only enough to achieve the 5G or 6G goals. So it should be more improvised. So whatever the features we are extracting, only the features. So the 5G things we can provide it when only we will get a 100% 5G electronics and a 5G device, as I learned from my professors. And next one, the green technology. So what is the problem? So the government encourages solar panels. It may be a controversy, but I need to tell, solar panels very good. But what is about the solar wastage? After few many of the years, it may become a big burden to the world actually. But maybe it is possible with a green kind of material, which will provide a green energy resources or green electronics. Okay, so nowadays the devices also disposable in a better manner, or which is not harming. So initially the batteries are harms very higher to the earth ground, but nowadays the batteries are replaced. The lead will be replaced with other materials, which is not at all disturb the environment, and these are also possible in a future. Next one is a automobile applications. So we have seen some visible sensors in the cars. Okay, in future we won't see anything. So a simple paint will give. It is used as a. It will be produced a power where it will be acts as a sensor. It can change its color and it can drive car itself only. The nano materials made these things true in future. Next one is solar cells, dye-synthesized solar cells. So which one I said, which is replaced the almost the current day solar cells, and which may be eco-friendly solar cells we are going to make in future. And next one, last one, the virtual technology. So we can do anything virtual with the help of nanotechnology in this virtual world. Please go for next slide. Okay, so what is after nano? Sir, what you said, the nano is we are doing from long years, right? Past it is nano, present it is nano. What I said, future is also nano. So what is about pico? That should be replaced, right? So I am telling nano is not a present one. It is a very old one, and it is not stops here. It is going very long. So then what is about pico? So after nano, the pico is may not be possible because of that is at the atomic level. So nothing is possible below the nano level, which is a final frontier. So which is given by the Richard Smalley. Nanotechnology is a builder for final frontier. You can go through movies, for example, Ant-Man, some kind of movies you can see. Very good picture visuals they are going to provide. Okay, some hero is going to go below the nano level or atomic level, then one science people will warn him, don't go below the atomic level or nano level, then you can't sustain yourself, you will be changed every time. So there's a no stability below the nano level, so that maybe the pico technology is not possible. Because of that, nanotechnology is the builder's final frontier. If it is possible, okay, we are achieving some more things which we made the stable things at subatomic levels also. So there may be may not be a pico. We can see the nano. Go for next slide. Go for next slide. So this is all about introduction of the nanotechnology. We'll see the revolution, industrial evolution of the nanotechnology. See here in these slides. In this slide, I'm going to give what are the different kind of discoveries we have. For example, at 3500 BC, before that 3500 BC, we have an industrial discoveries like we identified stone, bronze, etc. And 1764 we are industrial. 1906 automation, mass production is possible. It is also called as a consumer age. And in the year 1953, we are focused on health. Genetic engineering is going to develop, so it is called as a genetic age. And 1991, so industrial nanotechnology almost all occupies all the industries, so that we can call this one is a nano age. And the next after the 2020, nowadays we are in the year of 2020. So in automation, where molecular assemblers. So we are going to assemble one nano device to another nano device. So we are can call this era as an assembler is. So then after that 2050 we may call that as a life assembler. Maybe the lives may be assembled with one another. We can't say that. So this is the some history are useful for science. And the next slide. So next slide is also same evolution of the industry. In the 1784, it is called as a industry 1.2. So every 20 years what the industry's requirements are changed. Okay, according to the industrial requirement, the technologies are modified, and so that the social life and everything will be changed because of this industrial evolution. Economy is changed, so everything is changed because of that evolutions in the industry. For example, in the given slide 1784, it is industry 1.0. So where the mechanization and steam power are introduced, so the trial engines and everything will be coming to the picture. The next stage is called as the assembly is. So we are going for a mass production in the industry 2.0 1870s. And because of the mass production, the cost will become reduces more and more for industry 3.2, that is in the year 1969. So 1969, that is called as an electronics era, where the automation is possible from the electronics. And nowadays we are in the era of industry 4.0. So what is industry 4.0 is, so it is having with a network and cyber physical systems, etc., etc. So that so now whatever the invention we made, okay, so that is should match the industrial 4.0. Okay, so if we have in our curriculum a very old studies, okay, for quotation.
Sir?
Clear?
Sir. Yes, sir.
Humor is, and we can manipulate some issues from nanometer gold particles, so which are going to absorb 521 nanometers, which is giving a reddish color, and 1 nanometer gold particle are going to absorb the wavelength of the light at 420 nanometers and give a color of brown yellow. Okay, so that the color of the gold at a nanoparticle level is a depends on its a particle size. If the particle size is varied, here the color is varied. Okay, and the other properties also varied. And the next of that gold particle Hello, is my voice is okay? Next slide, please. Next slide. Next slide, please. Okay, so this is the slide will give the evaluation of the industry and industry 4.0 requirements, and 3D visualization is also provided. Thank you. So these are the top 9 trends in a nanotechnology for 2025. Okay, first one is carbon nanotubes, semiconductor nano devices, green nanotechnology, nano composites, nano sensors, nanofilms, nano capsulation, energy nanomaterials, and computational nanotechnology. And this is the slide which is drawn from an internet. So which shows that 1628 startups and emerging companies are analyzed, and they are working on these areas. So these are the very prominent areas for the year 2025, and the stats is also available in the net. So how drastically these domains are increasing day by day. So next one is nano electronic devices. So what are the nano electronic devices? Next slide, please. Next slide. Next slide. Okay, thank you. So the nano electronic devices are plasma displays, which is the production of displays with low energy consumption and which might be accomplished using carbon nanotubes. And next one is nano memory, where the electronic memory designs in the past have largely rallied the form of a transistors. So now our mobiles is also having the memory of 256 to 512 GB. And now the size, there is a no more hard disk in your laptops. Okay, it is SSD, solid state devices. Now that solid state devices are replaced with MMCs, right? So the size of the memory devices also reduces day by day, lesser and lesser, and at the same time so nano memory is good for an enhancement in nano electronic devices, and nano sensors that can be fabricated on the nanoscale, and nano transistors made using current high technology production processes based on traditional top down strategies. So somewhere some articles are given that there is a no era for the silicon and germanium. Silicon germanium era is over. The other materials are already occupied so many sensors. So that is where the nano transistors are also made with a different kind of material. And nano circuitry, to see the circuitry, researchers use an electron microscope of an atomic force microscope in future. And quantum computer has a quantum bit memory space termed as a qubit for several computations at the same time. So these are the electronic nano electronic devices we have in the market. Next slide is a video presentation. Please play it. Next slide is a video presentation. Okay, there's a no play option.
In 1946, the American public was introduced to the world's first general-purpose computer, named ENIAC.
Giant electronic brain is starting meditating at the University of Pennsylvania.
ENIAC was a gigantic leap forward for computing technology, but at nearly the size of a classroom, it was not very user-friendly. Today's computers, tablets, and smartphones are not only millions of times more powerful than ENIAC, devices that are now the size of tiny breadcrumbs and can fit inside everything from watches to pens to greeting cards. How have computers been able to get so small, fast, and have greater functionality? The answer is nanotechnology, the study of the manipulation of matter on an atomic, molecular, and supramolecular scale, where 1 nanometer is equal to 1/1000th of a meter.
Everything in information technology is really based on nanoscale devices.
Tom Tice is the director of the Nanoelectronics Research Initiative at the Semiconductor Research Corporation and a researcher at IBM. The initiative, funded in part by the National Science Foundation, studies one of the most popular applications of nanoelectronics, microchips, or integrated circuits, and how they could be made even smaller, while at the same time increasing their efficiency.
The smaller we make these things, the more of them we can make at the same time. They also get cheaper. And that's why now you have a smartphone that has the processing power of the biggest supercomputer from not so many years ago.
Microchips are composed of transistors, which are made of materials called semiconductors. Today, more than 60% of transistors built by U.S. companies make use of nanotechnology. As an electric signal flows through them, the transistors switch on or off, represented by the numbers 0 and 1, to digitally transmit, process, and compute information.
The image that you see on your phone screen is really represented inside the phone as zeros and ones, which correspond to on and off states of these many, many millions and billions of switches.
The first computers built after the ENIAC contained only about 800 transistors. The microchips of today typically house anywhere from 2 to 6 billion transistors, with wires that are only a dozen nanometers in width, a fraction of the width of a human hair.
We need switches to make computers, and the smaller we can make those switches, the faster they tend to be, the more information we can process.
As transistors and microchips continue to shrink in size, engineers are excited to contemplate what the next step in microchip evolution might be, how small they can go, and what they can be used for. Already, new applications have emerged, from social networking to environmental monitoring and medicine, and even more could come in the future.
Oh, so you could use the foil to charge the batteries?
Yes.
Ana Claudia Arias is an NSF-funded scientist at the University of California, Berkeley. She believes that if microchips were engineered to not only be flexible, but also be able to work inside the human body, it could mean a breakthrough for the future of nanoelectronics.
My research group in Berkeley is looking at how to fabricate flexible devices for several applications, for large area electronics or for wearable medical devices.
Arias and her team are currently in the testing and development stage of designing microchip-based electronic sensors made of flexible, biocompatible materials like gold and other conductive metals. These nanosensors could one day be physically implanted into a patient's body, collecting and transmitting valuable information to the physician.
One of the goals of our research is to have a suite of sensors that allows us to monitor all the vital signs, such as oxygenation levels in the blood, pulse rate, temperature, and possibly changes in blood pressure.
After a short time inside the patient, the nanosensors will be absorbed by the body, much like stitches. Nanotechnology will become more and more integrated into our lives in the future, but today we're already benefiting from this groundbreaking science.
Just about everything that humans are trying to do in science and technology is benefiting from advances in nanoscale science and engineering.
As microchips continue to become smaller, faster, and more powerful, scientists and engineers like Tice and Arias are continuing to push the boundaries of nanotechnology by making electronics and our bodies work together.
Please. It may be a bit long, but such a wonderful video, which is gives old electronics and novel electronics on the same place. So up to this, I introduce you what is nanotechnology and past, present, future, and how it is, what is the nano devices and how it is functioning. And these are the things we discussed up to now. And this is my contribution of the research. Uh, I, for my PhD thesis. These are the things I have done. So as we know, the materials as an electronic as electronic students, we know how we are classifying the materials. We are classifying materials into three parts, right? First one is a conductor, second one is a semiconductor, and third one is an insulator. Right. So, what is the difference? If the valency band and conduction band is overlapped together, then it is called as a conductor. So if it's a gap between energy gap between valency band and conduction band is 1 electron, it is called as a semiconductor. Where insulator it is even more higher, approximately 6 to 7 electron volts. But there is a huge gap between the semiconductors and insulators, approximately 2 to 5 electron volts. Uh, where we are stuck in electronics is that the semiconducting materials, because it is very easy to switch in between the 0 and 1s, as just we seen. But in many harsh condition, the semiconductors also works like a normal conductors, and these materials doesn't have some nano material properties, and that's why I get some literature survey, and I found out some gap here, research gaps in a material classification, that is wide band gap semiconducting materials. Next slide, please. And here some of the materials other than silicon and germanium, most probably metal oxides, which have started band gap from 1.1 to 6 and 7, but they are having a very good applications. For example, zinc oxide can act as a gas, having a band gap of 3.3, which is works as a gas sensor or OLEDs and solar cells. And see here, BaZrO3, its energy band gap is 5.3, which can act as a fuel cell, electrolysis cells, sensors, etc. So that even the band gap is higher, the metal oxides is also works like a semiconductor devices, and it is also extends its applications in the same electronic area. So this tables, and the next table you can see the different kind of electronic applications, which is a pure semiconducting material, approximately above the semiconducting materials and below the insulating materials. And I'm giving you with their dielectric constants also. Next slide, please. Silicon, titanium dioxide, cerium oxide, zinc oxide, SrTiO3, SnO2, PbTiO3, Ta2O5, Si3N4, BaZrO3. These all are good wide band gap materials, which will help the electronic applications, not all silicon and germanium, right? Next slide, please. And these are the some other materials, LaLO3, ZrO2. ZrO2 is a very good material for a corrosive application. But see, what are the electronic applications? We have oxygen gas sensor, and it is acts as an insulator because of good dielectric constant. And metal oxide semiconductor, it is also helps in a mass devices. Okay, by simply changing the gate material, we can change the electronics, like this kind of material, ZrO2 and Y2O3, ZrSiO4, hafnium oxide, L2O3, SiO2, and these are the some wide band gap semiconducting materials, which will help and supports in a electronic applications. For example, quartz is having a very high energy band gap, but the services of quartz for electronic applications is a very good. So these are the some of the wide band gap materials which is from the literature. Next slide, please. And students who want go for device fabrication, then what are the things we have for the device fabrication? First one, simulation. Second one, material or substrate selection. Third one, characterizations for properties. Next one, fabrication. Next one, device preparation. Next one, testing, packaging, and finally production and manufacturing. These are the steps. So you are going to do your projects. You can do your projects up to simulation level, So by simply using some kind of materials and by adding to the substrates, you can you can do some characterizations, and you can do that analysis, so that you can go for fabrication of the devices. So if the device properties are well suited, then we go for its testing, and finally packaging and production and manufacturing is also possible. You can extend your research for any of the extents in this list. Okay, these are the steps for the device fabrication. Next slide, please. And these are the some of the simulation tools which are used for nanotechnology for all kind of applications like LAMMPS and quantum ESP RESSO, and COMSOL multiphysics is vividly used for the sensor and sensing application, and ANSYS is vividly used. Almost all antenna people are going to use this ANSYS tool, and Gaussian tool, GROMAX, and NanoHub. These are the some of the simulation tools provider. Okay, by doing direct research with a nanotechnology, it is a very highly expensive. The facilities is also not at one place, so that it is better to go with some kind of simulation tool. If we get a better results, then it is good for the fabrication and other parameters. So that simulation is a first step for the fabrication if you want to go for nano device preparation. Next slide, please. Next slide, please. Next slide. Okay, so the first part in a material selection, you need to select a substrate or wafer. What is a substrate? Substrate is a flat microscopic object which microfabrication process take place, and wafer is a layer of the substrate. And we have a different kind of wafers. Some are active substrate materials and some are passive substrate material. Okay, then here. I gave you for wide bandgap semiconductor material classification, right? So that is the classification based on energy band gap, between the gap between the valency band and the conduction band. And here we have another kind of a material classification. Actually, the nano devices are going to use. So, for example, you want to call that material is an insulator, and its resistivity is greater than 10 power 8 ohm centimeters. If you are called it is a semiconductors, it is resistivity between 10 to the power of minus 3 to 10 to the power of 8. If it is conductors, its resistivity is 10 to the power of minus 3. Why resistivity? The reason is the material at a nano level can behave like a conductor. The very good conducting material can behave like an insulator. An insulator can behaves like a good semiconductor in a harsh environments. Right, so that this is also one kind of a material classification other than the energy band diagram. By using the resistance also, we can classify the materials. Next slide. And next step for characterization of either nanocomposites or metal oxides thin film. There we need to do a huge number of studies in a nanomaterial, nano devices. So as I said, at a nano level, the material changes its properties. A good conducting material can be as like a good insulator for some extent, and it acts as a good semiconductor for harsh application like that. So these are the different studies we need to do: physical studies, structural studies, optical studies, morphological studies, composition analysis, and electrical studies. For this, we need support with a different kind of research experiment. The next 2-3 slides, which are all the characterization equipments, you can see. Next slide. So these are the some of the characterization equipments which is given in the list. Next slide. Next slide. Next slide. Okay. So this is all different kind of characterization equipment to judge whether that material is suitable for optical application, or that material is suitable for electromagnetic application, or that material is suitable for electronic application or semiconductor application, or that material is having a superconductivity, or that material is having a super dielectricity. These are the things we can get with the help of that material. And I want to give you two slides here to explain the fabrication flow. So what is the flow we need to follow for the fabrication? Is the first step is a cleaning. So you need to clean your materials thoroughly, which is each material has its own procedure to cleaning, and you need to clean your substrates thoroughly, and you need to clean your devices and apparatus. Everything you need to clean thoroughly. So there are different kinds of cleaning procedures we have, like soap clean, solvent clean, HCl clean, HNO3 clean. Aqua regia is a combination of these all composition. By simply varying the water and acid, or water and base, by doing varying its concentration, we can use a different kind of cleaning material. And next one is oxidation. Generally we have a silicon wafers available, so we need to deposit oxide layer based on your requirement. For that purpose you go for oxidate it 1 hour for highly vacuum that is oxidation. And next one is a deposition. There are a different kind of deposition techniques. We have conventional depositions like spin coating, and what is that, spin coating, spray pyrolysis. So different kind of conventional techniques we have. Other than that, we have chemical vapor deposition and physical vapor deposition. So all the deposition techniques may come under these two deposition techniques. So each deposition technique is having its own advantages and its own demerits. So these are the some of the deposition technique. So first you need to clean the substrate, then you need to oxidize it, then you need to go for it, select one kind of a deposition techniques. After deposition, photolithography. You want to design a MEMS device, or you want to design any of the structure on your substrate, then you go for a photolithography. So the right side image where the coating, exposing and developing will shows how the photolithography will take place. An ultraviolet light is exposed through a mask which is fall on a photosensitive layer which is placed on the wafer. Later that layer is removed, finally we can develop the structure. Okay, so there is a two kinds of resist. We have actually positive resist and negative resist. Based on the resist we can see the three-dimensional structures on the developed thin film. Next slide please. Next slide. So, and next one is micro machining techniques. There are different kind of micro machining techniques we have, as shown in display. Polysilicon surface micro machining, bulk silicon micro machining, metal surface micro machining, Liga, silicon carbide, diamond and diamond like carbide, polymers, etc. So we need to handle nanomaterials at a very higher temperatures. If the temperature is rises, then the subatomic particles will come into the picture, and they are acts as what is that, they are contaminate actual the material, so that we need to reduce the temperature, operating temperature, but we need to perform a better operation of a lithography or deposition. For that purpose we go for different kind of micro machining techniques. Each micro machining technique is having its own advantages and disadvantages, and which are also compatible with a VLSI process, VLSI fabrication process, so that VLSI fabrication equipment can be utilized for this nanomaterial deposition and fabrication. Next one, etching. There are 4 or 5 kind of etchings are there: wet etching, dry etching, RIE and DRIE, wet reinforced. So different kind of etching techniques are there. So what is etching is, we need to remove the unwanted material to fabricate a three-dimensional nanostructures, three-dimensional structures. So etching process is helpful for that. And after that etching, the final step is a packaging. So there are a different kind of, the materials are nanomaterials, not only used for fabrication, not only used as an active material. So there are requirements of a passive materials, right? So see here, we can see Pyrox glass for constructing base, and metal casing to protect that three-dimensional device or MEMS device, or your integrated circuits, or your a nano device or nano sensor. So this is a different kind of packaging techniques we have based on the packaging technique, and we go for production and manufacturing. So this is the fabrication flow. So the fabrication flow involves of 7 steps. First one is a cleaning, second one is a oxidation, third one is a deposition, fourth one is a photolithography, fifth one is a micro machining, sixth one is a etching, and seventh one is the packaging. And I have only 10 minutes, right? So that I will speed up my presentation. Go for next slide. So this is the composition. I have a very good collaborator which are helped me as an electronic guy. I am going to do these all kind of research because of my collaborators and my friends. They are helped me a lot for the this preparation and fabrication steps. That's why I can present here. So this is the composition which is I chosen for my gas sensing application. So it is the ternary composite ZNO TiO2, and which are doped with SnO2 as a one composition, and which is doped with the CiO2 as an another composition. So those are the real-time images how we are prepared that nano composition. Next slide, please. And I have performed these different kind of characterizations to identify, to study the structural, morphological, and optical, electrical properties. And I studied very good properties, and it is also published in very good journals. Next slide. And for ZnTiO3 thin film fabrication, I go for physical vapor deposition technique. And these are the sputtering conditions what we are identified to fabricate my composition on a different substrate. I choose quartz substrate and n-type silicon substrate, platinized silica substrate for my device fabrication. Next slide, please. Next slide. And this is the fabrication of thin film. So you can see the n-type silicon material as a substrate material, and above on it I have a ZnTiO3 slightly doped with SnO2 or CiO2, and I studied the structural properties, morphological properties, optical properties, and electrical properties of the thin film. Then I concluded these materials also can help for gas sensing devices, as a gas sensing device. Next slide. So this is also same slide, but the substrate is varied here, platinized silica substrate. And so this is the gas sensing properties. No problem, you can go for next slide. Gas sensing properties, which I observed, it is showing a better sensitivity at a 300 degrees centigrade at 200 seconds, 200 to 300 seconds of time. And I am identified very good gas sensing properties of this material. Actually, this composition is used for based on oxidation and reduction techniques, which is chemical people are used generally for this dye degradation and photosensitive applications. We think that this gas sensor is also having the same kind of property. Why we can try it with to the gas sensing gas to prepare a gas sensor device. Finally, we succeeded to prepare a gas sensing device, and we can develop the outputs also. Next slide. So next slide. So these are the other properties, sensitivity, detection time, and response time, and recovery time with respect to the temperature which we are studied. Next slide. Next slide. So these are the job opportunities in nanotechnology for ECE students. Previously, job opportunities for nanotechnology for ECE students, right? So why nanotechnology? See here, I am acting as a in charge training and placement cell. So we in our electronics we have a different domains like VLSI and embedded systems, but nowadays this is the era the people are not satisfied with a single domain. So if you go for a multidisciplinary, then only your project or your profile will be withstand. So for example, so what are the students here doing here is they are going to when you go for image processing, you are doing only MATLAB initial days, but now the image processing can performed by the VLSI. Similar like so artificial intelligence, machine learning now entered into a VLSI and embedded systems. Okay, IoT is now entered into a artificial intelligence and machine learning technologies. So that now the technology is interdisciplinary. By learning only one technology, we can't solve the current issues. So it is better to go for different multidisciplinary sections based on your time and facilities. And why we go for a nanotechnologies? It is having a vast number of applications. What are the industries handling EC's nanotechnology? Semiconductor in industries and healthcare, biomedical device industries, energy sectors, aerospace and defense, and research and development. These are the people who are working on this nanotechnology electronics. Next slide, please. What are the skills required for this is so nano electronic engineer need of designing of nano size transistor and circuit, and MEMS engineer who need to be work on micro and nano electromechanical system, and nano fabrication specialist need develop nanoscale devices, and sensor designer need to understand nano sensors for IoT and healthcare, and quantum computer researcher need to explore the quantum devices, and material scientists need to develop advanced materials for chips and devices. Next slide. And these are the essential skills for success: semiconductors, physics and VLSI design, nano fabrication and lithography techniques, MEMS NEMS design with simulation, MATLAB console T code with Python for simulation, knowledge of CNTs with graphene and quantum dots, hands-on experiences with clean room technologies. Next slide, please. So continuously, these are the my projects with the student contribution, not yet published, under development level. So the multi-waveform generator. So this generator can perform all kind of analog modulation, demodulation, digital modulation, and digital demodulation techniques. Next slide. Next slide. So this is the second project, brain tumor classification using deep learning techniques. Initially, we are going to do this thing with a MATLAB, right? So now the machine learning and artificial intelligence will help better. So you can see the symptoms of that. If you are upload a photo of some tissue, then it will give what are the symptoms you have if that kind of tissue are there, and what is the strategies you are going to need follow to reduce its impact on human. So that is this one, brain tumor classification using deep learning. Next slide, please. It is an automated health graph generator. So while we are going to hospital, the doctor is going to give so many tests, right? And again, you need to go for doctor and you need to show him whether you have a problem or not. And this is a project which will read almost all kind of reports, and it will give whether the person is above normal or below normal, or it is in a normal condition. If it is an above normal, what are the problem he is having, and what are the reasons are there, and what is the medication he need to take, and what kind of the food culture he need to follow. Next slide, please. So this is another project, understanding the simulating stealth technologies for a novel vessels. Next slide. And this is the amplifying education. If this project is come into the picture, then no faculty need to maintain their timetable on a paper. It is now a displayed thing. So that is the project, amplifying education with a real-time announcement and instant updates. Next slide, please. And digit recognition, what I said, the image processing is now image processing and artificial intelligence, machine learning, deep learning through VLSI. This is a project. Digit recognition using Verilog based on CNN. That is another project. Next slide, please. Okay, next one is my publications. Last slide, please. Next, next, next. And thank you very much giving this wonderful opportunity to present work on this cutting edge in nanotechnologies and wide bandgap semiconducting material. So I am very thankful to entire technical team of Sanketka Vidya Parishad. Especially I am very thankful to Dr. Sunita Madam, our Associate Professor and Head of the Department Sanketka Vidya Parishad and management and students and viewers. Thank you very much, Madam.
Thank you, sir. Thank you very much for your wonderful presentation. It was quite informative. Actually, it is budding technology, right? In India,
Yes,
I think in India it is the budding technology.
yes,
And even the students is not having nanotechnology as a subject.
yes. It is
I think,
needed.
sir. Yes, it is. It is very much needed to have nanotechnology as one of the subject. I feel, and
Actually,
your
they are in a trap
contribution.
of VLSI and embedded systems. Only these two
Yes, sir.
they don't.
Yes,
But
sir.
the we if we combining these all the domains by doing our project only, we will get a good results. Otherwise, the same results we will see.
Yes,
You
sir.
can.
It is also one of the core of our EC, I think. And you should concentrate on nanotechnology is my feeling. And congratulations, sir. You have got good number of publications. And I feel your students, that is triple IT News Video students are lucky to have you. And sir, if our students want to communicate with you, is it okay for, I will share your mail ID with my students?
Anytime, madam. My lady and contact number, no issue.
Okay, sir. Thank you. Thank you very much, sir. Have a nice
Thank
day,
you.
sir.
Thank you, ma'am. Thank you. Shall I leave?
Yes, sir. You can.